This particular question is asking you to find the points of the graph where you have a vertical or horizontal tangent line and find equations of those lines. Well, to find a formula for the slope of the tangent line, we just need to take a first derivative, and that's important to remember that your first derivative is a formula for the slope of the tangent line. So if I go through with what we did yesterday, 2x plus 2y prime minus 10 plus 8y prime equals 0. The derivative of 16 is 0. And if I isolate y prime, I'm going to do that by keeping my y prime terms on one side of the equal sign and my non-y prime terms on the other side. So that's going to be equals 10 minus 2x. Factor out of y prime, and I have 2y plus 8 is equal to 10 minus 2x. And let's divide both sides, and then also let's take out a 2 from everything. I would get 5 minus x over y plus 4. And that's the first derivative. So the thing to keep in mind here is that it asks for vertical and horizontal tangent lines. And a vertical tangent line is a vertical line. And vertical tangent lines occur as vertical lines. Vertical lines are not functions. But a vertical line is basically whenever you have a vertical tangent. We've seen that whenever we divide by 0. Vertical lines is actually a representation of vertical tangents of when you divide by 0. So vertical tangent lines occur when the slope of the tangent line is undefined. And if the slope of the tangent line is undefined, that means that y prime has 0 in the denominator. So for the vertical tangent line, that would mean that that occurs when y plus 4 equals 0, or when y is equal to negative 4. Well, y equals negative 4 is not a vertical line, that's a horizontal line, so that's not going to help right now. We need to work our way backwards to figure out what that means in terms of this. So what I'm going to do is actually plug negative 4 back in to the original equation. And I get x squared plus 16 minus 10x minus 32 plus 16 equals 0. And I have x squared minus 10x equals 0. Or x times x minus 10 equals 0, or x equals 0, x equals 10. Those are going to be my two vertical horizontal lines, or vertical tangent lines. So I'm out of space, and I'm going to move over to the right while we look for a horizontal tangent line. Sorry, but you can attach a sheet of paper or something. A horizontal tangent line, basically those occur when the slope of the tangent line equals 0. And that occurs when y prime has 0 in the numerator. And that occurs on this particular one when the numerator, 5 minus x, equals 0. I'll put a little occurs when, and that occurs when x is equal to 5. Well, x equals 5 is not a horizontal line, that's a vertical line. So I once again need to go back and substitute, this time x in. So I have 25 plus y squared minus 10 times 5 plus 8y plus 16 equals 0. And that's going to give me y squared plus 8y. That's going to be 25 minus 50, so negative 25, plus 16 is negative 9 equals 0. And that will factor into y minus 9 and y plus 9 and y minus 1. And I have y equals negative 9 and y equals 1 as my horizontal lines. And then finally it actually asks me to graph that, or sketch a graph. I'm thinking that by the time I copy this for you, I'll have this fixed in terms of pages and grids and everything, or just make it more space. So let's just pretend that this isn't there, and I'll actually have a grid, or put a grid down. So I want the lines x equals 0. Actually, I'm just going to have you sketch a graph. X equals 0, x equals 10, y equals negative 9, and y equals 1. And those are our tangent lines. Well, clearly you can probably visualize that a shape could come and kind of fit in there, and that's going to be a shape of an ellipse, actually a circle. I could have gone back to the original equation, as you can see right now, and taken this and completed the square on, let's see, x squared minus 10x, and done plus 25, then plus y squared plus 8y plus 16 equals then negative 16 plus a 16 plus a 25, and I would have gotten x minus 5 quantity squared plus y plus 4 quantity squared is equal to 25. So this is a circle centered at 5, negative 4 with radius at 5. So that's kind of what we see here. Actually, I'm going to give you a real grid for that, so hopefully you would have seen that on a real grid. Okay. Next question, I'm going to erase this and use this space here, but again, you'll probably have this on a separate page. By an equation of the tangent line to the ellipse. So this is actually an ellipse at 2, 5. So I have x squared over 5 plus y squared over 125 is equal to 1. Take a derivative of the left and the right sides. Now some people find it helpful to multiply both sides by 125 now. I'm going to go ahead and do that, so I end up with 25x squared plus y squared is equal to 125. So when I take the derivative, I'm not dealing with fractions. That'd be 50x plus 2y y prime equals 0. And if I put y prime by itself, I can divide both sides by 2 first. And then I would get y prime is equal to negative 25x, or y prime is equal to negative 25x over y. And if it wants the equation of the tangent line at 2, 5, I'm going to find what y prime of 2, 5 is. Now it's worth plugging that in to confirm that that actually is an ordered pair on the graph. If I plug it in, I get 16 over 5 plus 25 over 125. And does that equal 1? Well, 16 over 5 plus, that's not 16, sorry, 4 over 5 plus 1 over 5 does equal 1. So that is a point on the graph itself. If I plug y prime in, I get negative 50 over 5 or negative 10. So use point slope form, y minus 5 is equal to negative 10, x minus 2, and I should get y is equal to negative 10x plus 25.